Lesson 4.5, we are going to deal with direct variation, okay? I want you to go ahead and write down each of these three things here. The first thing that you see is the direct variation formula. You have to memorize that formula. You will need to use it on your test and your quiz, and it will not be given to you. So you will need to know what the formula is so you can use it, okay? When we're talking about direct variation, what do the letters X and Y always stand for? Coordinates, okay? Or an ordered pair. They're always a place on the graph. So what we're talking about with direct variation is how one of the points relates to the other. But what happens if I only know one part of the ordered pair? What if I only know X? Is there ever a way to find Y? And yes, it is using this direct variation formula. The thing that you have to know, though, is the constant of variation. That is the letter K in direct variation. K stands for constant. Well, it's not spelled like that, but it stands for the word constant, okay? And we know that, think about what the word constant means. What is the word constant? Like if that was a vocab word, what does it mean, Josiah? It always stays the same. If something's constant, it never changes. So I know if I can find the constant, the part of the equation that never changes, I can plug in any number at all for either X or Y and solve to find the one I'm missing. So the whole point, if you look at this third bullet point right here, the whole point is to find K, the constant, and plug it back into our original equation. So that's what we're doing today. We are trying to find K. But before we do all that, let's look at these problems right here. We have Y equals K times X. That's our direct variation formula. And they've already given us an equation that is in direct variation format. And they just want us to locate. What is K? Now, when you're dealing with a direct variation problem, K is always a number. You will never actually physically see the letter K in the in the problem, okay? So, let's think about it. Our formula is Y equals K times X. So, K is always the number directly in front of X. In this example right here, they're asking us to find the constant of variation and the slope. Remember, we dealt with the slope yesterday. Now, this is kind of getting you ready to work on the slope-intercept form, which we're going to do in 4.6, but that'll be on the next section, next test. And the constant of variation and the slope are always the exact same thing. Always. That'll make more sense about the slope part whenever we go to do slope-intercept form. But until then, just know the constant is always the number in front of K, and our slope is always the the constant is always the number in front of X, and the slope is always the number in front of X. So, if they want us to write that, we're just going to say, all right, K is equal to what? What's K equal to in this first problem? -3. So then what's our slope? -3. There's your answer. Just like that. That's it. So that's for this first one. All right, Naeem, what is our constant of variation in the second problem? Mm-hmm. 3/4. So, JT, what's my slope? 3/4. That's it. So on this example, they just want you to be able to identify where that constant is going to be located. And it's always the number in front of X. If you notice, there is no K at all in this program. I keep saying that. Problem. It's represented by the number. Okay? So now, they want us to write a direct variation problem. What is the whole point of direct variation? What letter am I always trying to find? K. What did they give me in the example? X and Y. What am I missing? K. I've got to plug it in and solve for k. Because it's wonderful that I've got x and y. That's so nice of them, but that's not what I'm trying to find. I'm trying to find the constant so I can say, okay, what if I plugged in another ordered pair other than 5 and 20? Would it work? Would it fall on the line? Can I find a missing variable if I don't know what it is? Yes, so that's why we want to find the constant. So you got to know the direct variation formula in order to solve these. So what is the direct variation formula? Y equals kx, or k times x. So let's plug in the numbers that we know. We know that x is equal to 5 and y is equal to 20. So I'm going to write 20 equals k times 5. Now all we want to do is solve for k. Now the reason why I didn't write the 5 in front of the k, which technically you would want to, is because I just want you to see that each number, what variable it represents. So we would still solve the same way. How do I get k by itself? What would I do to the 5, Jordan? Divide. So what does k equal? K is equal to 4. This is not my final answer. A lot of people box that in and say, done, yep, whole point is to solve for k. I just did it. Yes, that is partially right, but when we are doing the direct variation problem, the correct final answer is you go back to your original formula, y equals k times x, and you only plug in k. So my final answer would be y equals 4x. That is my final answer. You say, wait a second, I know x and y. Why shouldn't I plug those in? Because the whole point of direct variation is to have that constant there so I can plug in other numbers for x and y. Like what if I wanted to say, look at the second part of this problem. X is equal to 10. Can you find y? Well, yeah, now that I have the direct variation formula, I can do that. So that's the whole point. We never want to plug in the x and the y. This is our final answer. So let's do the second part of the problem. Find the value of y when x is equal to 10. I've got a formula here that I can use now, y equals 4x. So let's plug in x is equal to 10. Y is equal to 4 times 10. What's 4 times 10? 40. Y is equal to 40. There's the second part of my answer. That's it. That's all we're doing for direct variation. Okay, next example. Same exact type. They want us to use the direct variation formula to find the constant. Once we find the constant, we're going to write our final answer, and then we're going to do step 2. Josh Center, what is the formula for direct variation?
Y equals kx.
Y equals kx. Perfect. Okay, Michael, what do I know?
You know x is negative 3 and y is negative.
Perfect. We know x is negative 3 and y is negative 30. So Josh Ferris, how would I plug this in?
You put negative 30 in for y and then negative 3 in for x.
Very good. Now, it's k times x. Even though x is negative 3, please do not get confused and say, oh, it's k minus 3. No, no, no. It's k times negative 3. That's why we put the parentheses around it, so you don't get confused. So what am I going to do to solve for k? Michael? Divide by negative 3. And what does k equal? 10. Is this my final answer? Can I box it in and say I'm done? No. How do I write my final answer, Christian?
You do y equals 10 times x.
Perfect. Y equals 10x. That is my final answer. That's my direct variation equation. So when it says write an equation that relates to x and y, there it is. Now the second part, find the value of y when x is equal to 10. Michaela, what am I going to do for that part? Very good. We're just going to take out the x and plug in an 8. So what does y equal when x is equal to 8? 80. Okay, that is your direct variation formula and how to plug it in. What are we always looking for in direct variation? K, the constant. What is the constant the same as? The slope. Very good. Okay, here is the homework for tonight, page 237, 16 through 20, and 24 through 30, evens only. Each section, you're only doing the even numbers.